Exercise 176, page 444, question 1. And there is an extension at the end of this question, having had a go at these, sort of like a part D. So part A, find the differential with respect to x of this function 3y squared. So what I need to do is to differentiate this function with respect to y, and then multiply that by dy by dx. So this is going to equal, what's the differential of 3y squared with respect to y? 6y. So this equals 6y times dy by dx. Part B, differentiate with respect to x the function 2 cos 4 theta. Well, what I need to do now is to differentiate in terms of theta, which is the variable inside the function. So this equals d by d theta of 2 cos 4 theta, and then multiply that by d theta dx. So differentiating the function with respect to theta, cos becomes minus sine, and the 4 comes out, so it becomes minus 8 sine 4 theta times d theta by dx. So quite straightforward. Just differentiate in terms of the function inside what you've got, and then multiply by the differential of that new function with respect to x, or the original function with respect to x. Part C, so now I've got to differentiate a function involving k, where k now is some variable with respect to x. So again, I need to differentiate the function in terms of k, of the square root of k, and then multiply that by dk by dx. Of course, I need to use the laws of indices to rewrite this function inside the bracket. So this is d by dk of k to the half multiplied by dk by dx. And I'm sure you can now finish that off and come up with the solution in the textbook. Have a go. But the solution continues as follows. So if I differentiate, this gives me a half k to the minus a half times dk by dx. Rewriting this as half times 1 over k to the half times dk by dx. And then k to the half can be written as a square root, so this is a half times 1 over the square root of k times dk by dx. And of course, this can be written as 1 over 2 times the square root of k times dk by dx. I've deliberately separated out this part of the function here into 1 over k to the half, so you can see that this is the inverse bit, and then you've got the half and the times 1 over root k. But of course, there's nothing to stop you just jumping straight from this term here, if you understand what's going on, to this term here. I'm just showing the steps. So that's part C. And then this extension question, part D. So I want you to differentiate with respect to t the function 3 over x squared. So have a go at it, and then have a look at the solution which follows. You should have got the answer, minus 6 over x cubed times dx by dt.